Okay, so starting with making it so that people can actually see it. All right, so the vocab for this time, we have 5 new words, or at least new words in this context. And they aren't, I mean, while they are in alphabetical order, they aren't in the order that we will see them or use them or what have you. Okay, so some first things. The first one we're going to deal with is parameter. And a parameter is just a way of customizing. Oh, wait, I got somebody here. Customizing a function so that you can do it a specific way. It makes it far more useful. Okay. And no, that's not it. Let's go here and turn that on so I can actually hear when people show up in the waiting room. Okay. So a parameter allows you to make a function a customizable amount. You'll see what that looks like in a second. Hexadecimal. This is our first look for hexadecimal. Hexadecimal is another number system like decimal or binary, except it's base 16, and each character, each digit can represent a number between 0 and 15. And the way we do that is by using letters once we get past 9, and we'll look at the odometer widget to explain that. API and library are sort of the same thing. They are built-in functions or built-in functionality to whatever software or service that you're using. Documentation is just the how-to. It's the manual for any programming language or design environment. It will tell you how things work or what it's actually supposed to look like. Okay, bubble 2. Let's get going with actual. Let's see, is this working? I think it is working. Okay, hopefully. If not, we'll just use an old recording. All right, so yeah, go ahead and give yourself full screen. Why not? Okay, so here we have our first look at parameters. Okay, a parameter is just inside of any function call, inside of the parentheses, that space is there or is designed, it's waiting for added information. Okay, so far when we've been writing functions, we've been writing them like, I don't know, setup, open close parentheses. Okay, the open close parentheses lets you know it's a function, but the use of those is by it's allowing an extra piece of information to make that function more useful. In this case, we now have the ability to put in parameters for our turtle movements. Okay, and that is how far each one goes. Instead of before where we had to do move forward 3 times to make it go essentially 3 lengths, we could just type in 75. And then in one line of code, we've made the line that we want. And instead of having a move forward for each length that we want, we have one move forward function that is customizable however we want to use it. Okay. And your challenge for this one is to see how many pixels you think it takes to get to the top of the screen, which I'll give you a hint. If you mouse over the screen, when your emulator screen, when it's not running, you can see the coordinates of your cursor on the screen. Okay. If you look at it closely, you'll notice that why is this weird? There we go. You'll notice, okay, so we're used to, hopefully, you're used to regular, there we go, Cartesian graphing where, like, if this is our first quadrant and we have the x-axis here, that's almost an x, and a y-axis here, and this is 0, 0, and we go up in the y direction this way, up in the x direction that way, that's normal. In computer science, it looks like this, okay? X still goes up as we go right, but y goes up, the value of y goes up as we go further down the screen, which means 0, 0 is actually up here. And that is the case for almost all, I would say pretty much all, digital design. And the reason for that, I think, is, or at least so I've heard, so web pages and everything on a screen loads top to bottom. And so it makes sense to send the first information first and work your way down, especially when you're loading a page. You don't know how long it's going to be, or the computer doesn't know how long it's going to be until all the data gets there. So it starts at the top, and you'll see that's true. Okay, if you look at the X value, it goes all the way up to 320 on this side, and Y equals 0 is the top edge, and it goes all the way down to Y equals 450. The resolution of our emulator in AppLab is fixed at 320 by 450, and normally you would have something like screen width divided by 2 to find the center, but here we have hard-coded numbers. More on that later. Okay, but here for this particular challenge on Bubble 2, we need to figure out how many pixels it takes to get to the top, which you can do this with trial and error. Let's see what 200 does. 200 almost gets me there. How about 250? 250 is a little too much. It's probably something like 225, where it depends if you're counting the tip of the arrow or its center or what have you. Depends, and that will affect it. But something like that is fine, and as long as you are calling a function that has a parameter in it, you're fine. Okay, let's go on to Bubble 3. Let me just refresh all of these so that they are loaded when we get there. Okay, Bubble 3. Eventually, I promise. Okay, Bubble 3, we now have our challenge of drawing this triangle. Okay, so far we've used move forwards parameters, or the parameter for the move forward function, to figure out how long it is. And here we want to make a equilateral triangle that is 100 pixels long on a side. So we know we can start with a move forward, and it looks like this is all to the right. So we're going to do a turn right with its parameter being an angle. Okay, you know it's an angle because over here in the toolbox, it is telling you what the number that you put in the parameter will affect. Okay, turn right is only interested in the angle you want to turn. Same with turn left. Move forward is only interested in the length or number of pixels you want to go forward. And that is a good hint as to what you need to put in there. Okay, and if we leave it at 90, it's just going to turn due east. But we want an equilateral triangle. Okay, an equilateral triangle has angles of 60 degrees on each side, or each of the angles is 60 degrees. But if we turn only 60 degrees, it's going to point that way. We want the supplementary angle of 60, which is 120. And 120. And there we go. And we just need this 3 times. Bingo. Okay. So we now have parameters being used for a couple of different things.
Okay.
What's up?
Chip Gabriel.
All right. Okay. So that's it for bubble 3. Let's go on to 4. Okay. Bubble 4, we get to talk about documentation, first of all. So, like I said, documentation is the manual. If you mouse over, the easiest way to get to documentation is to first mouse over the block that you are interested in. It will tell you the name of it and details. And if you click on examples, it will open up this window that has all of the different blocks that you can use in AppLab. And if you click on any one of them, it will tell you what it does and what it's supposed to look like and the parameters and everything. That is the documentation. Okay. Now we get to use colors. And if you didn't know how colors work, you could check the documentation. But we have a new block called pen color. Okay. And before we were only writing in black, and now we can choose any color. And the way that you choose a color, there's a couple ways to choose a color. There is a list of named colors in HTML and in everything, CSS, whatever. And I've printed or I've copied a link to the list of named colors, meaning colors that have a specific name attached to their RGB, and this is a hexadecimal number. Anytime you see numbers and letters mixed together, but none of the letters go past F, it's hexadecimal. But this is your list of named colors, but you don't need to use named colors. You can use this one. You can use several different formats. You can use the RGB format, which is one we're going to use a lot. And RGB is expecting 3 different parameters. The first one is the amount of redness on a scale of 0 to 255. The second one is the amount of greenness on a scale of 0 to 255. And the last one is the amount of blueness on a scale of 0 to 255. So red would be max red, 255 red, 0 green, and 0 blue. This is the RGB triplet for red. Okay. Other options, this one, RGBA, is the same for the first 3, but this 4th parameter is the opacity on a scale of 0 to 1, with 1 being fully opaque and 0 being invisible. Okay, if you want something to be translucent, you would use some version of RGBA. And the last one, hexadecimal. Hexadecimal is tricky, and you won't ever use hexadecimal to do like arithmetic, but it's really about placing or replacing longer descriptions of the same thing. Okay, so just a quick jump into hexadecimal. The way it works is, well, you'll see here, I'll show you a couple things. Okay, so decimal is regular and hexadecimal is what we're working on. So just the blue and the gold colored one. Okay, so decimal goes up to 9. And when you get to 9, it goes, the ones column resets to 0 and you add 1 to the next one. Hexadecimal keeps going in that column all the way up to F. Okay, F in hexadecimal is 15 in decimal. You do one more, we run out of letters in the first ones column. We increment the, what is the 16s column, and it goes back to 0. And there you can see how it keeps going up. It gets to letters and keeps going. Now, why would you do this? Well, the largest number you can make with a single hexadecimal character is 15, or F, but F means 15. The largest number you can make with 4 bits is also 15. That's not a coincidence. The largest number you can make with 2 hexadecimal numbers is 255, which is the same as the largest you can make with 8 bits. Okay, so the idea is that it shortens things, although if you don't know hexadecimal, it just confuses things. But either way, our hexadecimal code is always going to be, or usually going to be, 6 characters, with the first 2 being the amount of red, the second 2 the amount of green, the third 2 the amount of blue. In this case, the most you can make in hexadecimal is FF, and the least is 00. So max red and the other 2 off is red, and I think that's the 4th one. Okay, but here for now we can just use named colors, and our goal is to make this a blue square. So we definitely need to set the pen color. Let's just go ahead and call it blue. And does it say a size on this? That feels like about 100 pixels. Let's go 100 just to see the first line. And it's not thick enough. Let's use pen width of, let's see what 10 does. And it's not going to do anything different because I changed the pen width after I did move forward. Okay. So a pen width of 10 and blue looks like this. It might be a little shorter, but that's fine. Either way, we need to make the box, which is another turn right 90 and a total of 4 of those, I think. There you go. It's actually probably shorter and maybe a pen width of like, I don't know, 13. It's fine. As long as you have shown that you can change the color and the pen width and make a square, you're good for this bubble. Okay, let's go on to bubble 5. Okay, we get another one, the dot. Okay, the function dot draws a single dot wherever the cursor is. Now, the tricky part is we need to be able to move, where are the turtles? We need to be able to move the turtle. And in order to do that, we are going to need some understanding. Well, at this point, we don't need coordinates. We're still dragging it around one step at a time. But either way, our final goal is this snowman. And let's make, what's the first one? Fuchsia, magenta. Yeah, let's go fuchsia. Let's use fuchsia as the main color or the background color. And is that it? Snowman. Okay. So first thing we're going to do, in order to do the background, we're going to make a dot that is bigger than the screen. So we need to first change the pen color, and I'm going to use the named color fuchsia. And I'm just going to make a dot just to see if it looks like the right color. And it looks close enough. Okay, how big does the dot need to be? Well, let's see what 100 does. Okay, not big enough. The parameter for the dot is its radius. So its number, the number of pixels from wherever the turtle is to the outside is that value. So in this case, a radius of 100 means we're 200 across. The entire App Lab smartphone emulator is 320 pixels wide. And it's 450 pixels tall. In order to make a circle that covers all the way out, we're going to need to go bigger than well, honestly, it doesn't really matter so long as it's big enough to cover the screen. There's no reason to make one like 40,000 because, first of all, you can't tell. And it actually keeps track of stuff that's existing outside of the screen. And the more things you have keeping track of, the more things you're keeping track of, the worse the performance is. This is obviously not a huge deal when you're just doing a single dot. But if you have this dot that's like 40,000 pixels, it's on the other side of the room right now. And it's keeping track of stuff you can't see. There's no reason to make it that big. I think 400 is probably good enough for a background dot. Okay, and so to make the snowman, let's switch the pen color back to white. Again, we'll just use named colors for now. And we need another dot. Let's see what 100 does. I forget. 100 is a little big. Maybe it's fine. I'm not super concerned. What is 50? I can't not make it perfect or close. Yeah, that's fine. Okay, so we made our first dot at the starting location, size of 50. We need to then make another dot, and just doing a little back of the napkin math, if we have a move forward that is the size of this radius, the turtle will then be exactly on the edge. And our first dot is 50 in radius. So if we move 50 forward and then do another dot, I don't know, it's going to be smaller. Let's just guess. That second dot is not going to be where we want it because it will make it right on the edge. So we need to go a little farther than the size of the dot we're drawing on top of, but not twice. I don't know. You can just sort of walk it in. You sort of get close and do your best. Something that looks like that. But the second one is probably smaller. Thank you. And then a third one that is a little bigger than that or farther away. and then another dot of, I don't know, 20. Let's see what that does. Maybe a little more move forward on the last one. Maybe a little bigger dot on this one. All right. Well, this isn't really making a huge difference, but oh wow. So, either way, there we go. There's some more stuff. Not terribly difficult. Let's go on to bubble 6. All right, so now they're making us use hexadecimal colors, and they've given us 5 different colors to choose from, all in hexadecimal code or hex code. And like I said a second ago, in hex code, you are going to have 6 digits, or at least a multiple of 3. It's almost always going to be 6, which means 2 characters for red, 2 characters for red, 2 characters for green, and 2 characters for blue. You good? It's what? You need a charter? Okay. And so if you have 2 hexadecimal characters, the lowest number you can make is 0, 0. The highest number you can make is FF. Everything fits somewhere in between here. Okay. So AA is here. CC is here. 8, 8 is here. It's not always going to be the same one twice, but it might as well be. For here, it will be. But that is your scale. So if we are trying to guess which one of these, which one of these 5 color codes is which one of these 3 colors, that's what we need to know. Okay, so we need 1 red one, 1 green one, and 1 blue one. Let's see if we can figure this out. Okay, so we have in this first hex code, we have the lowest amount of red. So this is not the red one. We have AB as the amount of green, which is medium high. And DC is the amount of blue, which is even higher. And if they are different, just like with numbers, the second number is like in base 10, the second number is the tens column, the other one's the 1. So of these two, the more, I don't know, powerful one is the one on the left, or first one. So this is a medium high amount of green and a nearly to the top amount of blue. So this is a blue-green color. This one is near max red, medium low amount of green, and no blue. So that's a red color. This one is very low red, medium green, and nearly most blue. So it's another blue-green color. Same here, no red, medium amount of green, or medium low green, medium blue. So another blue-green color. And this one, medium low red, nearly the most green, and no blue. So this is a green color. Okay. Now, which one of these is which? Well, there was only one that was a red color. So we know this is our background. So I'm going to go ahead.
Sorry for the interruption. Can you send Ileana to sign out?
Yes.
Thank you.
We are still muted. Okay. So I know this is the only of those 5 that's a red one. I'm going to grab it, and the red one is the only background. So I need to set the pen color, and we are doing the hexadecimal code, and I'm just going to type it in. It's CC4400. CC4400, and we will make a dot, and we are happy with 400 as the size. And there we go. There's our background color. So next we need to figure out which one is this light green. And so we will change the pen color to a different hexadecimal. So of these, This is more blue than green, so it's not that one. This is more blue than green, so it's not that one. This one is more blue than green. It's not that one. This one is almost all green. So we'll try that one. So this is, let's switch it to the hexadecimal format. And we are looking for 11CC00. And, oh wait, we got to make a dot. We may have changed the color, but there's no way of knowing because we didn't draw anything. And there we go. Okay. And then the last one, let's figure it out. We want a light blue color. And so of these three, no, of these two and this one, they're all majority blue, but the brightest one is going to be the one that has the highest average of its code, which 1188CC is medium, but this one has a super high amount of blue and a pretty darn high amount of green. I'm going to try this one. I think this is the brightest blue. And so we got to go like that and like that. 00 AB DC, and then another dot of, I don't know, it's probably 50 just to guess a nice round number. Oh, maybe it's not that. Okay, so we need a darker blue. This is another blue. Let's just try this one. 1188CC. 1188CC. There we go. That's the one, I think. Yeah, it is. Okay, so that's all we need to do for 6. We've got color parameters now. It's nice. All right, so some more tools. Arc left, arc right. Arc left and arc right both require 2 parameters. I don't know why I jumped to 45 there, but the 2 parameters, the first one is the angle of rotation, or the angle. Let's just go ahead and throw one in there. Angle, let's just see what this looks like. Okay, so the first number is how many degrees of the circle you want to draw. Okay, up to and including 360. Let's see what, no, wait. 270 would be that far around. Okay, and the other number is the radius, which is the distance from the hypothetical center to the outside. Now, it's important to note that the circle is drawn from the location of the turtle, wherever it is, the turtle starts drawing, but your radius is whatever that hypothetical center point is. And obviously larger is larger. Okay, so with that knowledge, we need to now make this shape. Okay, does it say powder blue? It is powder blue. Let's go ahead and do the background, which is just going to be a dot. Obviously, we need to change the color. How about, oh wait, powder blue. I do not think it is case sensitive. Yeah, it is not. And 400 is another good one for that. Okay, and so let us draw some purple arcs. So we need to change the color again. Pen color, and do they just call it straight purple? It is purple. And let's do some arcs. Okay, so it's clearly going to be left, right. But if we start out with our arc left and make it 180, it is going to turn that way. Obviously, I had forgotten, but now we're reminded we need a larger pen width, which can go anywhere above where you start arcing. I don't know, 7 maybe? I don't know. That looks fine. The other issue is this starts out pointing east. So we need to turn right before we start our left-right progression. So we need our turn right, so again, somewhere before we start drawing, and 90 seems fine. We turn right, and we go like that. Okay, let's do, we have an arc left. Let's throw an arc right with the same dimensions on there and see if that looks good. Okay, I don't think I'm going to be able to fit 3 of these in a row, so I'm going to shrink it a little bit. Does it give you actual dimensions? So it's the radius to make that smaller. Let's try 15, and it's definitely going to be the same for both, whatever it ends up being. Yeah, it looks good. So we need a total of 3 of each in order to make this work. There you go. Might be a little wider. 10 maybe? It's actually probably even smaller. It might be like a radius of 10, but this is good for us right now. Okay, so we've got colors, we've got arcs. We're great. Okay, bubble 8. All right, so this is our first look at RGBA, or red, green, blue alpha. Alpha is the opacity, talked about it before, and it's on a scale of 0 to 1. When you bring out the, well, there's a couple different blocks. There's the pen RGB block, where it has 4 discrete parameters that it's expecting. The other one, the pen color, you can switch to our 4-parameter one. It just looks like that. These 2 things do the exact same thing. They aren't doing the same thing now because this would be red, and this one is setting it to 50% opacity, and 1 is full opacity. So if you did like that, these 2 blocks would be the same. But either way, it's a 4th parameter. If you only give it 3 parameters, it knows those 3 are red, green, and blue. If you give it a 4th parameter, that last one is the alpha, and it knows what those numbers are going to be applied to. You have to know what a useful range is. Okay, if you put 1000 in here, I don't think it will break it, but it's never going to be 1000 red. It can't go above 255. And same thing with opacity. It can never go above 1. Okay, the numbers that go in the parameters are applied specifically to whatever you have to know a useful range. Okay, so let's actually start. We need to make this. Okay, so first let's pick a color. Magenta maybe. And let's dot. I think that's probably a 50 dot. Let's see what that looks like. Okay, not too bad on color. You'll see in a second. Obviously, it's off. And that is because, wait, I already forgot. We need to do pen RGB. We need to do RGBA. Either pen color and switch it to that, or this one, like I said, I already forgot. Okay, so let's see what's a good fuchsia color. Fuchsia is going to be a lot of red, a lot of blue, and no green. So maybe 200, 0, 150. Is that going to give me fuchsia? A little dark. Let's go a little bit higher. But redder. I don't know. I could just, it doesn't terribly, that's close enough. Okay, and opacity needs to be 0.5 or something less than 1. Okay, not too bad. Now we need to move the turtle. Okay, right now we just made this first translucent circle here. We need to move the turtle up so that we can make our second circle. So we need to move forward, and it looks like the center point here for this circle is exactly on the edge. So our move forward should be the same size as the dot. Okay, so we're moving forward the same amount the dot size is, and we hit go. And the problem is you can see the turtle's trail, because even though it's at 50% opacity, we've drawn a 50% opacity trail over a 50% opacity circle. What we need to do is actually use pen up. We don't use pen up a lot, but we can throw a pen up at the beginning. Pen up only affects turtle movements. It doesn't affect dots. So you can dot with pen up. Okay, so then we moved it to here. We need another color. I know it's going to be 50% opacity. This is a heavy blue color, so I'll max out blue, and it's kind of purpley, so maybe 150 purple and no green. Let's see what that does. Also, we need a dot to actually see what it does. Dot of same size. There we go. Okay, so new things are opacity. You saw a little bit of the figuring out RGB colors. I don't know. When in doubt, you can always just find a website or a color picker, or there's plenty of apps that will give you, yeah, it will give you, I want to tell me, okay, yeah. So RGB, there's your RGB triplet is equal to this hexadecimal, but that's neither here nor there. Where were we? We're here. Okay. So that was bubble 8. Let's go on to 9. We're doing great. And okay, smiley face. So this is where we get specific coordinates required. Okay. We have move to and turn to. Up until now, we've only had move forward, which moves the turtle forward in whatever direction it's pointing. And we've had turn right and turn left, which only turns the turtle a certain number, whatever amount of degrees, but based on the way it's pointing. Move to makes you put in or allows you to put in an XY coordinate to have the turtle jump to a specific location. And turn to allows you to have the cursor, the turtle, point to a specific angle irrelevant of what it already is pointing to. That is useful because when you rearrange things, you might have a turn to switched or turn switched order, and that will affect things. Okay, so we are trying to recreate this, and let's, well, we know we want a dot that is going to be, I'm just going to use named colors. It's a little bit easier than trying to walk in a specific RGB value. So make it powder blue and a dot that's big enough to cover. And make sure everything works. There we go. And so we need the head of the face, or the head, the face. We need to change the color. Let's make it just regular old yellow. And let's make a dot. And if the entire thing is 320 across, okay, our entire emulator is 320 across, that means a circle or dot with a radius of 160 will touch both edges exactly. And I can prove that with math. Okay. And I don't want it to touch both exactly. I'm going to make it 150. And the reason for that is this was made by a person and they probably typed 150 instead of 140. But also, I need the smallest amount of not touching. And if I make it 150, that means I'm using up 150 of my 160 that I have in each direction, which means I have 10 pixels left over, which is what I want. All right, so now we have 3 more components. And actually, I would like to start using comments. Okay. I also want some white space. So I'm going to switch it to text mode and add a couple forward slashes and then switch it back to block mode. That will give me some white space. The comments are, the comment block is in the functions tab. And all a comment is, it's just a portion of code that the program ignores. Okay. It's places to put notes to yourself like fix the thing that, and then or something like during this part, this function does this or that. But it's a good way to keep track of things for other people to look at, but also for your future self to know what's going on in your own code. So let's put comments where that explain what's going on. So let's this powder blue dot is a background, and then the yellow dot is the head. And now we need to do some other things. We need left eye. It's also a good way to plan out your to-do list. Let's go right eye, and then a mouth. Okay, so we have three more components to do. And what do we need? Well, I need to figure out what coordinates this eye exists in and put a dot there. Okay, so what are this XY coordinates? Its X value is however far from the left it is, and its Y value is however far from the top it is. Okay, so let's just guess. Okay, and we'll make an educated guess and then figure it out. Okay, if this is where I want the eye to be, I know my hypothetical center line is 160 from the left. So it's going to be less than 160. Let's try 100 from the left. And so let's see what move to X 100 looks like. And the Y location. Okay, so this hypothetical horizontal center line is half of 450. The whole thing is 450. So that means this center line is 225 from the top. And so this is going to be less than 225. Maybe, let's see what 190 does. And 190 in the Y. I actually might be way off. It's been a while. And we need a dot. That's probably, let's see what 10 is. And we definitely need to change the color back to black. And let's see what happens. Okay, so it drew the line because we had a pen up, which the best way to do this, or to make sure you don't make mistakes, is anytime you have a move to, put a pen up in front of it and a pen down after it. That way, your move to functions are never going to draw the line that they go on. Okay, I'm not crazy about this spot. It definitely needs to be a bigger dot. And it's not bad. Maybe a little bit more to the right in X. So let's try 110 maybe. Would increase the X. We'll push it a little to the right. Yeah, that's not too bad. Okay, so if this eye right here is at 110, 190 is its XY coordinates, Y being the distance from the top. That's what we have. What coordinates are this going to be? Is this going to be? Well, it's definitely at the same Y level. So we know the second coordinate is going to be 190. What is the X coordinate going to be? Okay, well, if this is 110 and our center line is 160, that means this eye is 50 to the left of the center. Subtraction, right? So let's put the other eye 50 to the right of the center so that they are centered. Okay, and our center is 160. To add 50 gets us to 210. So let's try 210, 190 as our, well, I'll get a pen up, move to, pen down. Well, we actually didn't even need to do pen down, but that's fine. What did I say? 210, 190, and then another dot. That was 20. Pen is already black. Boom. Maybe a little bigger. It's fine. I actually like that. Okay, so the mouth. what do we know about the mouth? Well, we need to find one of these starting points, which is going to be like here. We need to turn it to point south. And if we move it here, we need an arc left. If we put it here, we'll need an arc right. I'm going to try and find this spot and then adjust everything else. So if I want to find this point right here, okay, if this is 160, this is probably like 180 in the Y direction. And this is 10. This is what, 110. It's probably like 50. So what I say, 50, 180 maybe? Wow, that's weird. Um, let's see what move to 50, 180 looks like. 50, 180. And that is not it. It's not 50, 180. It's 225 plus a few. Let's see what 250 looks like. And I still need a pen up. And let's see what that looks like. It's not bad. Maybe a little bit more in the X direction would be 60. Okay, I'm happy with that. I need to need to point it south, which is 180. Okay, here, straight up is either 0 or 360. 90 is east, 180 is south, and so on. Okay, so we turn to south. And because we're here, we need an arc left. Let's just see what we have when we put it in there. Okay, well, we definitely need to change the color back to black, which I thought it already was. How does it do that? Oh, do you know why? Because the pen is still up. So wherever I did pen up, move to pen down, that's fine. Okay, so now with pen down, it's going to draw. Clearly that's not big enough. We definitely want it to be a 180-degree turn. We definitely want the pen width to be a lot more. Let's see what Ken looks like. Okay. Pen probably a little more, but let's figure out the radius of the arc. Okay. If right here is, where's my move to? This is 60 from the left, which means that it's 100 from the center point. And if it's 100 from the center point and I want this arc to be centered, I need the radius to be 100. So I definitely want a circle of or arc with a 100 pixel radius. And we're getting close. And probably a bigger pen, maybe 15. Beautiful. Okay. Maybe a wider pen, but that's fine. Okay. And that is the process for solving that. Okay. I do want you to keep it neat. Thank you. Okay, bubble 10. I think this might be the last one. Maybe, maybe not. And okay. So, it does say somewhere on here, make your own design. You are not making your own design. You are drawing this. Okay. If you went ahead and did something else, fix it. This is what we're doing. Okay. People that fly ahead on their own usually do like the bare minimum, and that's not the point of this. Okay, we are going to recreate this as best we can. Let's go ahead and we could put some comments in here. We can just go ahead and type them. How about background? Um, Letter I. Letters C and S and heart. Okay, and that is what creating comments in text mode looks like. It's the same thing as dragging out the comment block and writing things. Okay, so do we get colors here? What color does that look like? It's like pea green or something like that. It looks sort of green yellow, lawn green, lime. Oh yeah, let's go with pale green. I think it's pale green. Okay, so let's do full screen. Let's set pen color to the named color pale green. And let's do the background dot thing, which is a radius of 400. Let's see what that looks like. Fantastic. Okay, then for the letter I, we need to either get it to this point and draw down, or get it to this point and draw up. It's already pointing up, so I'm just going to make it to this point and draw. Well, no, I'll tell you why in a second. Because we're going to need to refine the points, I'm going to make it to this point and draw down. So this point right here is definitely going to be centered. So I know it's going to be a move to 160. And because we're moving, let's just go ahead and do the pen up, move to, pen down as a standard triplet for this class. It will prevent issues. Okay, so this is 160 from the left, and this is not very much from the top. So it's going to be like Y10 or something like that. And let's see what Y10 looks like. And let's see where the cursor gets to. Okay, so 10's not enough. Let's see what 20 does. We'll work on it there. We need it to point south. So let's do turn 2. We could technically do turn right or turn left 180 degrees, but we want to stick with turn 2 as much as we can, because if you switch the order that things happen and you're using turn 2 at 180 degrees, if the thing you did before left the cursor pointing west and you did a turn right 180, it wouldn't be pointing down the way we want. So we're going to use an absolute direction of having a point due south. And we have the pen down, so we can just do move forward to draw our shape. Let's see what 100 looks like. Okay, and we don't have the color yet. It drew a line, but it drew it in pale green. So I need to change pen color some point before we draw. And that looks like purple. Okay, and I'm happy with the size or the length of it. I need a wider pen. Let's see what 15 looks like. It's probably 10. Let's stick with 10. Fine. Okay, and we'll do the C and the S next, just because we already have the pen purple, and that's fine. I guess it doesn't save us that much. Okay, so for the C, I'm going to make it to this point, point west, and then do an arc right. For the S, I'm going to make it to this point and do 2 arcs, an arc left and an arc right. And you'll notice that the sum of the arcs, the 2 arcs for the S, are the same as the 1 arc for the C. So this radius is going to be half of what the C uses. Okay, so I'm going to try and find this point. This point is a little bit to the left of our center line, and our center line is 160, so maybe 150. Okay, so we'll do another pen up, move to, pen down, just for good best practices. Pen up, move to, pen down. And my exposition that I liked was a little bit less than halfway. Halfway is 160, so maybe 150. And its Y position, if this is 450, this is, let's try 425 maybe. 425 and see where that puts us. And why did it disappear? Move 150. Oh no, move. I need to do move 2. Excuse me. Move is based on where it is. Another one based on where it is, not an absolute location. Okay, so that puts us over here. That is not, oh wait, also I typed it wrong. 425. Puts it here. I think it needs to be a little higher. Let's try 410. And maybe a little bit to the left. Are you kidding me? It's going to force a reboot. No. All right, we got 5 minutes. Let's crush it. Why is it doing that? What a horrible thing. Okay. So that puts it here. Let's do we need to turn to, oh, this is bad. Turn to due west, which is 270. And we need an arc right. And our arc is going to be the full 180. And the radius, the size of it, that looks like the right size for the S. I'm going to go 50 because that's going to be twice for the C. And I think it's too close to the center. So actually, I'm going to move it a little bit to the left, which is a lower X, which is what's less than 150, maybe 125. There you go. And so now I'm going to do the same thing for the S, which puts it right here, which is going to be the same Y height. This is still 410, but this one was 125 from 160. I want the reciprocal or whatever adds up to it. So that's an extra 25. So that's 185, I think. Okay, and this is going to be very similar. I need a pen up, move to, pen down. Oh, this is also the C and the S. And we still want 410. I want 160 plus this difference. What was it? 185. Let's see what that looks like. Okay, not bad. Let's do an arc left. It's a 180-degree arc, but it's half the size of the other one. So it's 25. And then an arc right, which is 180 and also 25. There you go. But the problem is there's a little bit of a short move forward here. You can see it doesn't look exactly right. Let's throw a move forward in before we turn left. And another one after we finish the right. It's probably smaller, but actually that looks right. Okay, so the last one, the heart, I'm going to find this point. Okay, so I want to find this point. So I'm going to do another pen up, move to, pen down. And those of you listening, if it crashes, finish it. Just read the checks for understanding. Hopefully it doesn't crash. And okay, so I need a pen up, move to, pen down. And what are the coordinates of, I'm aiming for the bottom of the heart. Okay, I know the X coordinate is going to be on the center, which is 160. And the Y coordinate is close to the very center. The center is 225 from the top. I'm going to say 250 from the top. Let's see what that looks like. Yeah, I'm happy with that as the bottom of the heart. Let's do a turn 2. Due north is 0. Actually, I don't want it north. I'm going to turn it to northeast, which is 45. And I think this line is 50. So I'm going to do a move forward of 50. Now, I also obviously need to change the color. So let's do a pen color. Before we do the move forward, pen color red. And there we go. And I think this is just a regular arc left of, it ends up being 180.